Okay, next step. What is a cycle? Specifically, what is a thermodynamical cycle? What does a cycle do? If I start at point A, what will a cycle do? Yeah, right. After it has done certain things, it must go back to point A. So a thermodynamical cycle is a series of thermodynamical processes done on a system that returns it to its initial state. Okay, we will be using the first law and the second law. What do we know from the first law? Delta U equals Q plus W. And what do we know from the second law? Must be, the change in entropy must be positive or equal to 0. Over the entire cycle, what should delta U be?
0.
Good. But Q and W will not be. So for each individual steps, you will have either Q going in or work coming out or whatever else is going on. But over the entire cycle, delta U must be 0. Okay, so ideal cycles must be quasi-static. What does that word mean?
Not changing.
Yes. So they go from one equilibrium state to the next, slowly changing. Number 2. So one was they must be quasi-static. Number 2 must be locally reversible. What does the word locally reversible mean? Since they're changing slowly, if you were just to reverse them backwards, they will slowly come back. Locally reversible means that if in a step, they go so slowly that when you repeat, like if you were putting mass on something on your piston, if you were to take the same amount of mass, they will repeat itself. Okay. Also, ideal cycles, do they exist in real life? Right? So we will study them for ideal cycle and then we will figure out how wrong we were. Good? Okay. And also number 3, must have no drag or friction. So in this particular course, you guys will be dealing with 2 things. I thought really hard about these names, and this is the best I came up with. So they may not match with other textbooks. So I'm calling them work to heat transfer cycles. And the other one, I'm calling them heat transfer to power cycles. And it's very clear if you think about what I'm saying here. What does the work to heat transfer imply to you? And what does heat transfer to power imply to you? What are you doing first in the work to heat transfer cycle? So you're doing some work to transfer heat to where it doesn't want to go. Get it? Or cool, like either way. To transfer temperature from one place to another, where it doesn't want to go. The second one is heat transfer to power cycle. What do you think is happening there? You are transferring heat in order to do work. So the first type of cycles are, for example, your heat pumps. For example, your heaters or your air conditioners, right? You're providing work which is forcing heat to transfer from where it doesn't want to go. So what does heat do? Naturally, it will flow from hot to cold. This room, outside is cold. What do you want this room to be? Right? Warm. So what do you have to do? Naturally, if this room was hot, where would the heat want to go? Outside. But from outside, you have a heater that injects more heat into the system. So that means you have to provide work for it. Got it? Okay, number two. Number two is the heat transfer to power cycle. In this case, you are using the fact that heat flows from hot to cold to generate power, like the way it's done in power plants. And in our cars, and in our planes. Okay, so there are different types of cycles that are given in your book. And I believe we discussed them in the labs. So guys, find your name, find your project, find your cycle. Write it down. I don't care if you write down every single cycle, but I want you to write down your cycle. Because you are responsible for explaining your cycle to the class. And they are in the book and beyond.